Hello everyone. Today I am here to present my topic, Information Extractor, a unified framework for information extraction from multimodal sources. Today we talk about digital world. We are in a digital era. From ordering food to ordering anything, we can do it digitally. But what is this digital world based on? This digital world is based on the data, and each byte of data contains story, just like a human do. Just like a human is away from a human with just a click, and in the similar manner, a byte is connected to any other byte in a similar manner, just a click away. So the question arises: is everything online? Definitely, no, not everything is online, because there are many things that are even today in a physical form and may remain in the physical form in the coming years. So in digital format, we have the feature called Control F, where we can search anything that we want in the document. We don't need to do it manually. Like, okay, we have to not scroll each and every page and search for, okay, this word is here or this word is not here. So we can use the Control F there. But what about physical documents? Physical documents need to be scanned manually. We have to do it manually, turn page by page and search for anything. That takes a time and also so many efforts. So what we do is we bridge the gap between the digital and the physical documents with our information extractor. So this is the simple basic UI which we have made for the information extractor. And information extractor, as I said, that is developed to bridge the gap between the physical and the digital documents. So basically it works on the OCR, computer vision, and face recognition technologies, which automate the information extraction from various documents. Moving ahead, so what do this do? As I mentioned, that it bridges the gap between the digital and physical documents, but it also recognizes any image similar to the input. Like if I give it an input that it is particular face of an image, face of a person, that you have to search whether it is presented to the all the images of the physical document that is given to you, or in the even in the digital format. So is this face or any face resembling to this is there in the document or not? So it will search that one and give us the most accurate result. And other thing is that it searches text in image of text. Like if we write something even in handwritten or in the document format, we click its photo and give it to the information extractor and ask that, okay, is this keyword there, is this phrase or line is there in the document or not. It will tell us, okay, if there is it, if there it exists, it will tell us, okay, at this line, this it will highlight that, okay, this is here. And if not, it will show us that, okay, this line that you search for is not in the document. So this is how it works. And basically we have used Tesseract OCR in this. So Tesseract OCR particularly stands for optical character recognition. I think it is self-explanatory that it optically recognize the characters that is there in the document. Second is that Tesseract is an open source OCR engine maintained by Google. It was earlier developed by some other company, but later bought by Google, as Google do, and make it very large scale. So yeah, OCR is a widely used and a great product by Google. And we have trained Tesseract OCR on our custom data. Custom data means we have given it hundreds and thousands of images and told it like this is the input, and so. And it can read physical documents like digital one, as I mentioned earlier. Now, more about OCR, that is optical character recognition. So how does it work? It just takes a normal document, which we give it in the image format or so. It do the binarization, and then it changes into it into components. Components are basically small sections of a document that we have given it. And then from there, it detects the word, paragraphs, and other lines, and first of all, analyze them separately, and then analyze them in a group, and then recognize it and give us the result. Explaining it more, I would say that when we give it an image as input, like here we have done, it do the pre-processing. What does pre-processing means? Pre-processing means it smooth, filter, deskew, flattens the image. Like sometimes you have seen, like if we uh, use a notebook and we click its photograph, it's somewhat inclined in between. So that inclination is removed and that is made flat, and so that the characters that we have to recognize can be made easier. And it basically regularize the color plane so that it will be easier to read the text for the machine. So it's called pre-processing of data. And then it detects the line. First of all, it detects the area of text. Like if there is a very large page and there is only 5 to 6 words in the page at some random points, so it will not wholly scan that. It will just first find the area of text. Where are the text in the image? So it will just consider that, and after considering that text, it will first check the line. If there is a word written, that it will check from where it is starting, upper point and lower point, which can make it easier for that to recognize the text. And then it checks the space between them, space between the words. Like if we have write NAT, national conference, NAT, the space between N and A and T, so that to separate the words out. And then it converts it into a very high contrast thing called bitmap. Bitmap is basically the image that we have, characters we have recognized, it converts it into a high contrast thing that is used for searching the text in the document. Okay, so after that it finds it in the document and gives us the result. Moving ahead, this is one of the result that information extractor do. Obviously, I have used a zoomed in image for this purpose, to make you show that okay, this is how it works. But it can work for any other image also, in which the word is not even clearly visible. Like here it is, the vaccine diplomacy. There is a word diplomacy in it, and I have searched for it like in the text word. If I show it to you, here I have used entered the word diplomacy. Here the file type, and here the language. It is a bilingual software. That means it can be in Hindi or English. Later on, it can be added in some other languages too. And here we gave the file of the input, like the newspaper cutting that I showed you earlier. So, and then after submitting, this is the result that we get. Okay, this highlights the word diplomacy that we have searched. Moving ahead, we have also the feature of face detection and recognition. Now, face detection and recognition are two different things. Detection means, okay, the machine is able to find, the software is able to find, okay, this is the face, but it don't know that whose face is this and are its feature, and so it just detects face. And recognition means you recognize, okay, this is the image, the face that we have is the of this XYZ person, and it has a certain XYZ features in it. So we have trained it on large database to detect and localize human faces within images. As I showed you earlier, and I'll show you in later slides the results of how it searches the image. So it uses various factors like Euclidean distance and cosine and other parameters too. Okay, so there is the face verification and authentication in this. It can recognize and detect face and physical documents like digital one, as I mentioned. So here is the working. It uses various algorithm and learning. So, but the main feature like it works is, first of all, when we give it a face, it what it do is it takes everything separately. Like it call it they call it blocks. But if we get it a face, it will separately analyze the eyes separately, analyze the nose separately, analyze the ears, and so it will do everything separately and make it's a unique facial signature based upon the collection of all these. Like if it has analyzed eyes, okay, this is the color, this is the size, this is the shape, and so, and separately for each block, and then it combines them all to make the face. And when after combining it all, it creates a unique facial signature that is unique for a person and can be identified very easily. So this is the working. And moving ahead, this is the flow chart of how it works. It starts, take the input image, then it divides the face into block. As I mentioned, then ear separately, nose separately, and other things separately, chin separately, to make the face model like longer, shorter, round or so, and then operate on each block independently, then combine the result, face image processed, and result is shown. This is how it works. And this is one of the result that I mentioned. This is the image that we have given it. Obviously, we have here presented a very zoom image so that to make it clearly visible to you guys. So this is the image that we have given. This is the search phase that we have given as input. Okay, if this person is there in the document, please let us know. So as you can see, the pose is not very similar, cannot be identified. One is like this and one is like in the other manner, but it can easily identify the person. So that how it's work. And thank you everyone. That's it for you, today.